welcome back to my channel, and we were discussing solving recurrence relations using linear algebra. Okay, so in part 1 of the video we saw what were the bases and how the recurrence relation was converted into an matrix equation that we saw in part 1. If you haven't watched that, please you can check out from the I tab above. Okay, watch that video first. Then in part 2 of the video we discussed about eigenvalues, eigenvectors, characteristic equations, their intuition, and we solved till we found S, the matrix S. Okay, and yes, for the eigen, we calculated the eigenvalues for the matrix A and the corresponding eigenvector. Okay, so we'll continue in this part 3. We will find we will first find S inverse. Okay, what is the value of S inverse? Then at the end I will tell you the geometric or real life meaning of S and S inverse. If the video gets too long, I might explain you the meaning of S and S inverse and why it helps finding the solution for closed form of the recurrence relation in the part 4 of this series as well. That might happen. Okay, so let's get started. So today what we will do, in last video we found out the value of S or the eigen vectors for the transformation matrix A. So let us see what was the value of that. 2 1, first column 2 1 and second 1 1. Okay, this was our matrix X. So for this matrix S, we need to find S inverse as well. So how do we find that? We can use Gauss-Jordan elimination method. Okay, elimination method. I will give you a quick geometric meaning, real life meaning as well of why Gauss-Jordan elimination system works. Okay, so first I will tell you what we are doing. Okay, so I know that a matrix S, when it is multiplied with its inverse, what will happen? It will give you the identity matrix, right? So we know the value of S, 2, 1, 1, 1, and we don't know S inverse right now, so we will write it A, B, C, D is equal to the identity matrix 1, 0, 0, 1. Doesn't this equation look similar? Doesn't it look like AX is equal to B, where I know that X, what are the dimensions of X? It usually looks like this, 2, 1, 1, 1, and X would be say X1, X2 is equal to B1, B2, right? B1, B2. It is usually like this, where X1 and X2 are representing scalars, and we are moving X1 units on first column as basis and X2 units on the second column, right? So can we treat the columns of this S inverse like we are together writing two scalar vector stacked like a matrix, and this S when scaled with AB will give you equal to the first column of the identity matrix, and when you take input as CD, when it is transformed using S, it will give you the second column of your uh, identity matrix. Okay, think about it. Pause the video and think about it. You will get it. Okay. So this means that what we can do is this equation is nothing but solving two equations of lines together. So first equation would be, I can break it down like this: 2 1 1 1 A B, giving you the first column of your identity matrix 1 0, and so these are equation of two lines, right? And second, that will give you the first column, the solution of the equation of these two lines, the point of intersection of these two lines will give you the coordinate of A and B, right? And that are your first column of your S inverse. And 2, 1, 1, 1 times CD is equal to the second column of the identity matrix. These are also again equation of two lines, two different lines. We will call this one as L1, this one as L2. Then this line will become L3 and this line would become L4. Now the intersection point of L3 and L4 will be CD. So that means we are solving together as a single unit total 4 equation of lines. Okay, they are different lines, so their point of intersections are different. Okay, so how do we do that? That means we have to do elimination, right? Elimination method, what intuitively elimination method does is, suppose I know what is a type of equation of a line, right? Ax1 plus by is equal to c y1, okay, and write c1, and the equation of the second line will be of the form c, okay, we use different variables, otherwise you will get confused with abcd. Okay, we will use u and v. Okay, u times x1 plus v times y1 is equals to z1, let us say, and we will use k times x2 plus L times y2 is equal to m, right? These are the equation of two lines. I know their point of intersection is same. So let us say the point of intersection is, okay, we will not take x1. Um, we will just erase it here. We will not take x1, y1 because it's equation of a line, right? So let us say the point of intersection with that both of these two equations satisfy is, let us take the value as what variables when P and Q, okay. PQ is the common point of intersection of these two lines. That means P comma Q, X equals to P and Y equals to Q will satisfy uh, both the equations, we will take the constants on one side, okay, or we can take constants on the other side as well, no problem. Okay, that will satisfy the equation if we plug in PQ in both the equations of line, because it's common point of intersection for both the lines. So U times P plus V times Q is equals to Z, and K times P plus L times Q is equal to M. We know that. And we know that in an equation, LHS is equal to RHS, LHS is equal to RHS, right? And in normal elimination method, what we do? We multiply a row with a scalar and we subtract it or add it to another row. This is what we do. And we know that this side LHS is equal to this side. Okay, let us say this is equal to a constant, right? These two sides are equal, and let us give another name to this constant, okay, capital A, okay. And I know that this side of the equation and this side is equal, and that is equal to a constant B. So if we add these two equations, what will happen? This side is equal to capital A, and you added this side of the equation, second equation, that is equal to the constant B. And I know that right hand side is also, for the first line, is equal to A, capital A, and the right hand side of the second equation is also capital B, that is a constant. So I know still the point of intersection is same. It is like you are just, by adding these two equations, you are getting the equation of a new line that has the same point of intersection. So it will give the same family of lines. Okay, it is not the same equation of line, but the family of lines that has the same point of intersection P and Q. So by doing the row operations, what you are doing is, or elimination row operations, you are rotating lines which pass through this common point. And ultimately what we do is, our goal in elimination is uh, that where we stop in elimination process, we try to make uh, below this in the matrix, below this in first column, below this first P, we try to make everything zero, right? And that is the row echelon form. And below this second Q, we try to make everything zero, right, for the second equation. So that is, we try to convert it is into an upper triangular matrix, making all the lower triangle as zero. So what in real life it does is, it will try to make, this was the point of intersection PQ, okay, P comma Q. Now this is your x axis. So we are coming, we will rotate, keep rotating by adding these constant, multiplying by constants and adding this equation to form new equations of line, till from this point of intersection we get two lines which are parallel to x axis. That means we will get finally x equals to P and y equals to Q, two lines which are parallel to the original x and y axis. That what this Gauss a normal elimination method means. Then you find the point of intersection PQ very easily. Okay, I hope you understood what the normal matrix elimination method or row echelon method mean, how it is helping to solve the equation of two lines. Okay. Okay, or we can leave this. Okay, fine. Let us move to the next concept. So why were we? Yeah, we were talking about Gauss-Jordan elimination. So I told you the intuition about the matrix elimination or the row echelon method, the row operations. What does it mean in real life? Okay. Now let us move on to using Gauss-Jordan elimination method to solve these two equations in a combined manner. So we will combine the elimination process for these four lines into a single step. Okay. So what we will do is, we will write the augmented matrix. That means we will remove this A, B, C, D. Okay. We will write only the A part. A part is same for both the equation, right? So we will write it like this: uh, 2 1 1 1 2 1 1 1. Then we will give a dotted, and then we will write this right hand side part together. Okay, like this matrix form will write 1 0 0 1 1 0 0 1. So now what we will do, combined we will do the row elimination methods. Okay, so first what I will do, I will replace row 1 with row 1 by 2. Okay, if you, after keeping doing the row eliminations, okay, what we will try to make, we will make this side as identity, and automatically the point of intersections will give you the columns of S inverse, right? I hope you have understood why it is giving S inverse, because here the solutions of AX equals to B will give you the columns of S inverse. Okay. So how do we change row 1 to row 1 by 2? We will multiply by the elementary matrix, pre-multiply. So half times the first row, okay, and 0 times the second row will be your new first row. Okay, and 0 times, what will be replaced by the second row? 0 times the first row and 1 times the second row. Okay, uh, this is how an elementary matrix, elimination matrix is written. 2 1 1 1 1 0 0 1. Okay, so after doing the operation we will get over here. Okay, always remember, I used to do this mistake. You should do this row operations both on the left side as well as right side. I told you why, the intuition, right? Because LHS is equal to RHS, so you have to add to both the sides or do the same operation on both sides. Then only it remains valid. You are getting a valid equation of a line that has the same point of intersection. Okay. So after doing this operation, we will have 1 half 1 1 half 0 0 1. Okay. Now what we will do, next operation, we will keep row 1 same. We will, what we'll do, row 2 will be replaced with uh, row 2 minus row 1. Okay, how do we write that in matrix form? Okay, so first row is same. Okay, the second row, what we do, minus 1 times the first row plus, right, the 1 times the second row will be replaced with the second row. So after this, what we will get is 1 half half 0 um, 0 half minus half 1. Okay, and we will, what operation now we will do, we will replace row 2 by 2 times row 2, then we will get 1 over here, correct? So how to write the matrix for this, that would be, first row we are keeping same, so 1 times row 1 plus 0 times row 2, and pre-multiply always means you are viewing the rows. Our rows are representing equation of the lines. Okay, always remember that. Okay, and okay, yeah, and 0 times the first row plus 2 times the second row is your new second row. So what we will get from here is 1 half, then half 0 0 1 minus 1 2. Okay, now what we will do, we will replace row 1 with row 1 minus row 2 by 2. Okay, how do we write that? 1 times row 1 minus half times row 2 will be replaced by row 1. Okay, and then row 2 is remaining the same. So what we will get is 1 0 then 1 minus 1 0 1 minus 1 2. So finally this has become identity, and this is our S inverse. Okay, we got our S, we got our S inverse. Okay, this is our S inverse. Okay, so in next part of the video, we will see the real life meaning, or in real life, what does S mean, what does S inverse means, and then how powers of the matrix A is calculated, A ki power k, and how do we get the closed form of the recurrence relation we discussed in the first part. Hope you enjoyed this video. Please share it with your friends, subscribe to my channel, and keep learning, keep exploring, and just be better than you were yesterday. Don't take pressure, have fun. Bye bye, take care.